All right, example 3. In the 2012 Summer Olympics, Usain Bolt won the 100-meter dash in a time of 9.63 seconds. In the 1964 games, Bob Hayes won the same event in a time of 10.0 seconds. Suppose these two champions could have run against each other at those same speeds. How far behind in meters would Hayes be as Bolt crossed the finish line? So, Bolt's getting there faster, therefore he'll cross the finish line before Hayes, right? So if I, just to draw a general picture of what's happening, if I say that's 100 meters right there, and this is Usain and this is Bob. All right, Usain runs the entire distance, Bob is running less distance. All right, so this is the distance Usain runs, this is the distance Bob runs. Looking at what's going on here, if we get a meters per second time for Bob, that might be our best bet. So let's look at Bob's speed. We know that his rate is the distance he ran divided by the time it took him, right? And he ran exactly 100 meters. This is the rate of Bob. Bob ran exactly 100 meters in exactly 10.0 seconds. If we divide 100 by 10, that gets me 10 meters per second is Bob's speed. If we look at the rate of Usain, he ran exactly 100 meters, and it took him exactly 9.63 seconds to do that. This, of course, does not divide as easily, so let's do 100 divided by 9.63. To figure out Usain's speed is 10.3, let's go 4 decimal, it's 10.3842 meters per second. So that's everything I can figure out by what they told me, right? So now I need to see what's useful. Okay, sometimes things are useful, sometimes they aren't. But again, based on what they told me, I knew how far both runners ran. I knew how long each runner took. So distance divided by time got me the rate of each runner in meters per second. The question says, as Bolt crossed the finish line, right? How much time did that take? How long did it take Bolt to cross the finish line?
9.63 seconds.
Bolt crossed the finish line, it took Bolt 9.63 seconds, right? So, we're going to have Bob run for 9.63 seconds, right? Everybody buy that? Okay? Because again, if Bolt's crossing the finish line, Bob's behind him, right? As soon as he crossed the finish line, in that time, that's how long Bob's been running also. So Bob's time is 9.63 seconds. Bob's rate is 10 meters per second. Okay. Rate times time equals distance, right? So that equals how far Bob would have run. Second cancels second. So that's 96.3 meters. So the moment that Usain Bolt would have crossed the finish line, Bob would have only been 96.3 meters into the race. The question says, how far behind would Hayes have been? So this is 96.3 meters here. This is what they're asking us for. Let's call it X to give it a name. How would I find X?
100 subtracted by 90.
Exactly. I take the entire distance 100, subtract how far he ran, that's how much is left over. So 100 minus 96.3 comes out to 3.7 meters behind. Okay. So Usain's speed is actually not necessary to get the answer to this problem. One thing you might be interested in that we have the capacity to do at this point if we wanted to, we could find out their miles per hour speed if we wanted to, right? Doing all our unit conversion from other chapters. So let's just take, I'm going to take a look at Usain because he's faster. That's more interesting. Meters per second.
You're probably going like 30.
I'm going to say something in the 20s probably. I think humans can't run faster than 25 maybe. I don't know, we'll see. So if I'm going meters per second to miles per hour, I know that 1,000 meters equals 1 kilometer. And 1.6093 kilometers equals 1 mile.
I'm thinking like 20.
and 3,600 seconds equals 1 hour. Pretend that's up there, right? Seconds on the bottom, seconds on top, right? So meters cancels meters, kilometers cancels kilometers, left with miles. Seconds on bottom cancels seconds on top, leaving hours on the bottom. So this divided by this times that. So we get, oh shoot, 10.3842 divided by 1,000 divided by 1.6093 times 3,600 comes out to 23.23 miles per hour.
It's not much faster than DK Metcalf.
DK Metcalf ran that fast?
DK Metcalf ran 2.64.
Okay, keep in mind this.
22.64.
Yeah, keep in mind this is an average speed, right? So his fastest, he started at 0, right? So his fastest speed along the way is probably faster than that, but just his average speed over 100 meters is that. So if you had like a radar gun on him, maybe at some moment in time it's probably more than that.
I think Daniel Jones hit 24 miles per hour on that touchdown.
Daniel Jones did?
Yeah,
24?
yeah,
Quarterback?
yeah.
Unlikely.
No,
Alright,
you had-
that's why he tripped.
10 divided by, okay, he's run so fast he tripped. I'm just putting Bob's speed in. You say Bob was 10 meters per second, so it just changes that number there. Everything else is the same, just to see how fast he was going. 1.6093 times 3,600 comes out to 22.37.
DK Metcalf.
So a little bit slower.
Metcalf would be on.
Anyway,
No.
there you go. That's how you do it.
it.